Okay, let's look at this one together. Our non-migratory birds of several species contain an average of 5.57 kilocalories per gram. Our average barn owl mass is 500 grams, so we can calculate 500 grams times 5.57 kcals per 1 gram, cross out the grams, and we end up with 2,785 kilocalories, right? Which is the average energy content of a barn owl. Okay, this next one here we're going to look at, we need to know, right, the total number of prey eaten in 1 year. Okay, now as we look at this, we have prey per pellet. You could kind of set this up two ways. You could do 44 prey per 15 pellets, right? And I would take that first and just calculate that out. All right, so let's look here. 44 divided by 15, equals 2.933333. Okay, so I am going to go 2.93. Okay, now as you look at this, there's going to be you're rounding, so you're going to need to, as we put this in here, 2.93 prey per 1 pellet. That's the simplified fraction there. All right, you realize that in the spreadsheet it's going to be slightly different, okay, which is times 1.4 pellets per day. I got that from right here, okay, per 1 day, and then times 365 days in 1 year. All right, so if we look here, we do 2.93 times 1.4 times 365 equals 1,497.23. And that is, again, let's label this unit. Total prey eaten in 1 year. Now, technically, the unit would be prey per year. All right, but let's spell it out really quickly there, or really clearly there, okay? All right, so as we can see here, right, that's pretty close. Our number was 1,497.23, 1,498.93 repeating would be without our rounding error. That's how we're comparing the two. So you can see if we set it up this way, we'll still get a very similar answer. We won't get the exact same answer, right? But we'll get the same answer as the spreadsheet, okay? So we have our 44 prey times 1.4 pellets, right, for 1 day, times 365 days in 1 year. So we cross out prey, this is why they make erasers. We cross out pellets, days, and our unit will be prey per year. So we input on our calculator, or do in our head, 44 times 1.4 times 365, right? Divide by 15. 1.1498.93 repeating, right? And that is prey per year. Okay. So as we look at here, we're calculating the relative abundance, right? The ratio of individual species relative to the total number of individuals. All right, so we have 44 prey total, and we found 0 voles. Okay, so our relative abundance of voles would be 0, or our proportion of voles to total prey is 0. So we would set this up again, 13 mice per 44 total prey. And we would divide 13 divided by 44. We get 0.295, and we'll round that up to 0.3. And as you can see here, that's the same number from the spreadsheet. Again, we're rounding here on the spreadsheet. This was why we were supposed to be checking here our different values. So here we have them set up for all of the rest of the prey. And again, you should see those match or come close to matching these numbers over here. So now we're going to calculate the average number of each prey species per pellet. All right, so we're going to put in 0 voles, 15 pellets is going to give you 0. But let's do a real one. Let's do 13 mice divided by 15 pellets equals 13 divided by 15, 0.86 repeating. And this is mice per pellet. All right, so a little less than a mouse per pellet. And you should see that value is the same as this value here. This is not rounded like I wrote on the paper. Here are the rest of my calculations for number 4. And again, these are pretty close to what is on the spreadsheet. Okay, let's look at number 5. All right, we need to know the total mass in grams of the prey consumed. The mass is on the spreadsheet. Okay, so this is set up for voles. I'm just going to cross it out and call it mice since we didn't have any voles. All right, and you can see I can go up here and get this value right here. 0.867 mice per 1 pellet. All right, now mice weigh 20 grams. That's one mouse. All right, remember our rate is 1.4 pellets per 1 day, and there are 365 days in 1 year. Okay, so as I look at that, I multiply across the top 0.867 times 20 times 1.4 times 365 equals 8,860.74. All right, and we go through our units here. We cross out mice, pellet. We have grams and days. So now we have 8,860.74 grams per year. Okay. And if you look here, that is the same setup I have here. Right, I'm very close, slightly off for a rounding error, but not far off. And this is my formula here. This number, right, times this number, right, that's the grams, times 511. 511 comes from 1.4 times 365. Okay, so here is our problem set up for each one. For mice, there's rats, there's shrews. Now there's moles. That is coincidental that the two are what they are. 5,110 grams per year, the answer for both. That's just a coincidence. And then there is birds. And as you can see, those numbers match up there with a different rounding for birds. Now we've looked at these calculations, but remember what the question asked us here. Calculate the biomass consumed by the owl in 1 year. Okay, so it's not just how many mice it consumed. So what we look over here, we have to add every one of these together. Okay, and that's what I've done down here. We tally all of them up, it comes out to that number there at the bottom. That's the total biomass in grams per year that the owl consumes in a year. And as you look on here, these numbers are all tallied up for you in this sum of BI down here at the bottom. Ours is a little different on the paper, but again, that's going to be due to rounding. Okay, so for number 6, we're going to look at what it says here. According to the literature, the average energy content of the mammals upon which owls feed is 1.58 kcals per gram, right? What we want to do is convert this, the energy content of the primary consumers or growers of this food. So we're converting these grams we have up here to kilocalories. So let's rewrite it. 72,564.74 grams per 1 year times 1.58 kilocalories per gram equals, and we're going to have to write it down here. Seven, 2, 5, 64.74 times 1.58 equals. Sorry, there it is. I'll write that under here. 114, 652,289. And remember, up here we're crossing out grams and grams. Kilocalories per year is our new unit. Okay, so for number 7, when we look at it here, right, we're calculating the predicted annual energy requirement of the barn owl. Okay, so we have 54.8 grams. 54.8 grams of food, right? And 1.58 kilocalories per 1 gram. Okay, so we're going to cross this off, grams food. We're going to come out with kilocalories per year. So we're going to take 54.8 times 365 times 0.58 equals 31,603.16. That is kcals per year. Okay, in this calculation down here, right, we're making some assumptions. We're assuming that herbivores, right, all of our organisms are herbivores. We know birds aren't. Birds are omnivores. But we're just making that assumption right now, right? And we're also assuming that the voles require 17.5 kilocalories a day. We're assuming everything's going to be that. We're calculating the amount of energy from the grass needed for all the prey of the owl. Okay. Now this calculation is the old calculation, but we can still use it. Because really all we need to do is change this to 44. Okay. So as we look at 44, we can cross out days with days, right? Prey with prey, and we end up with 44 times 0.5 times 365 equals 281,050. $281,050 kilocalories per year. Right? That's the energy from the grass needed. Okay? Okay, so we're plugging in our value here, 281,050, right? Over top of their value here. And again, in this one here, we're calculating up here the mass of grass needed. Okay? So we're going to take that 200,081.50, right? We're going to cross out kcals and kcals, right? And we're going to take that, right? Times 1 would be the same number. So we're going to divide it by 4.08, which gives us 68,884.8. And again, that is grams per year. All right, let's look at the last one here, number 9. All right, we're going to sketch a pyramid of biomass and a pyramid of energy. All right, and you're plugging in the numbers you've already calculated for each energy level. So it should be something that looks like this, right? There's 500 grams per owl, 72,564 grams for prey, and 68,884 grams for grass. Now, some of you might initially be thrown by this, but remember our numbers here, right? They are, I'm trying to find them on the paper here, sorry. 4 kilocalories per gram is what our grass is outputting, and our prey is outputting 1.5 kilocalories per gram. Okay, so our grass is much more efficient at putting out energy than our prey is. All right, and that would probably stand to reason. Okay, and as we look over here, we have our energy transfer from our grass to our prey to our owl. Okay, so as we look here on number B, right, there's our grass to rodents, about 41% of the energy is transferred up. And C, from rodents to owls, you get about 2% of the energy transferred up. Okay, So we've got our pyramids made. We're going to look at this last one, and this is an error in here. So those of you that made it to number 8 and didn't know what was going on, it's actually the estimated energy is going to be number 7, right? And then they call it predicted annual energy right here, right? Down here, sorry. The predicted annual energy. All right, that's at 31,603.16 kilocalories. Okay. And that's number 7 with the actual energy content based on our data. That would be number 6. So that is the 1,114, 652.289 kilocalories per year. Okay. So compare those two, right? That's the last part. All right, so we see that the estimated energy, right, is much lower than the actual energy consumed. All right. So what is the energy transfer in the owl pellet food chain? That's our claim. All right. Use data to support your claim. So you use the numbers, and then scientific reasoning. To the concept of ecological efficiency and how it's applied to our experiment. And then finally, 2 possible reasons your data might not fit this rule, right, of ecological efficiency. So our data is going to be off from that. Why do you think that would be? That's how we wrap this lab up. Sorry about the confusion with it. Hopefully you got something out of this video. It took like an hour and a half to make, so hopefully it's worthwhile.